7.5 interrupt in 8085 microprocessor executes service routine from interrupt vector location. Here RST 7.5, whenever a microprocessor trying to execute, it first go to the vector location, means it is having some kind of an address. So 7.5 is nothing but is equals multiply with 8. So what we will get is 60. This is decimal value. So convert 60 into hexadecimal, that is C, because 48 means 12, that is 12 is represented in hexadecimal C. 0. This is 3. Okay, 16 3 is 48, so 12 is going to be left, that is represented in hexadecimal as C. Now it is 0, this is 3. So the location address in case of 8085, the address is 16-bit, so we have to represent 003C, that is hexadecimal form, that is option C is correct. Of Z is given as follows. We have to decide what kind of filter it is. See, if we write h of e power j omega, a0 plus a1 e power minus j omega, b0 plus b1 e power minus j omega. As omega tends to infinite, it is going to be constant. As omega tends to 0 also, it is a constant. Yes or no? So from the given options, what we have to decide is, just option A is look at all pass filter. If a0 equals to 0 and a1 equals to b1, it's not acting as an all pass filter. If we substitute, it is going to be 0 somewhere in the infinity, so it's not passing in a highest frequency. So it is not an all pass filter, it is not a low pass filter. So the condition for an all pass filter is a0 must be equals to b1 as well as a1 must be equals to b0. Hence option C is correct. An 8-bit D2A converter has a full-scale output voltage of 20 volts. The output voltage when the input is 11011011 is. Here V0 is calculated 1 by 2 power 8 is the step size into 2 power 7 the weight of individual bit positions, 2 power 6, 2 power 4 plus 2 power 3 plus 2 power 1 plus 2 power 0, which is equals to 219 by 256 into 250, which is equals to 17 volts. That is option D is correct. Sum of an e power minus x square is. See, in order to decide this one, we have to apply the Fourier integral, but it is a standard form also. See, the Fourier transform of e power minus at square leads to root pi by a e power omega square by 4a, that is omega is nothing but 2 pi f, so omega square is 4 pi square f square. Here a is nothing but 1. So Fourier transform of e power minus x square is equals to root pi e power minus 4 pi square f square minus 4. So option is root pi e power minus pi square f square, that is option C is correct. Of zeros to be padded to the given x of n whose length is L and y of n length is M. L is greater than M. For implementing a linear convolution using circular convolution of x of n and y of n is. See, before proceeding into the solution, we have to know the length of the linear convolution of a sequence x of n and y of n is L plus M minus 1. This is the length of the sequence we are going to get after performing a linear convolution of x of n and y of n. Now, so for performing circular convolution of x of n and y of n, they must be of equal length. So we have to pad the number of zeros to x of n as L plus m minus 1 minus L, which is equals to m minus 1 zeros. The number of zeros to be padded to y of n is equals to L plus m minus 1 minus m, which is equals to L minus 1. So option A is correct. Following is a false if pi of t is a straight transition matrix. Here pi of t is nothing but e power at is the straight transition matrix. Pi of minus t is nothing but e power minus at, which is also equals to e power at whole inverse. Hence pi of t is nothing but pi inverse of t. This is correct statement. So pi of t1 minus t2, which is nothing but e power a t1 minus t2, which is equals to pi of t1 pi of minus t2. This option C is also correct. Here pi of t1 t2 is equals to e power a t1 t2, which is not equals to pi of t1 pi inverse of t2. Hence option B is the wrong statement regarding the state transition matrix. Hence option B is correct. Control system is described by the following state model. We have to find out the system is stable or unstable or marginally stable. What is the status of the system? So before deciding that one, we have to find out the transfer function of the system from the given state model. That is, transfer function is nothing but C Si minus a whole inverse into B. Here C is nothing but 1 1, B is nothing but minus 1 1, Si minus a whole inverse is nothing but S minus 8, S minus 4, 0 0, S minus 8, S minus 4. So 1 by S minus 4, 0, 1 by S minus 8. So transfer function is equals to 1 1, S minus 4, 0 0, 1 by S minus 8, minus 1 1. Here if we find out a transfer function, we will get that 1 by S minus 4 here 1 by S minus 8 minus 1 by S minus 4 plus 1 by S minus 8. This is the function we are getting. Now look at the pole locations. We will get all poles are located in the right half of the S-plane. Hence the system is unstable. That is option B is correct. Stable system. What about the gain margin and the phase margin? We have to say both are positive or one of them is positive, other is negative. Then which one of them is positive, or both of them has to be negative for the stable system, we have to say. So for the stable system, the gain margin as well as the phase margin must be positive. So option A is correct.